Section 1.5. Add to your understanding science notes, energy and motion. The purpose of this lesson is to introduce the science content that is being presented through this investigation. Students are introduced to the term energy and are asked how their prior knowledge of this word relates to the context. Most of your students will probably use energy on a daily basis, such as I'm tired, I don't have much energy, or turn out the lights to save energy. In this section, the focus is for them to take the word energy and use it in the way that scientists and engineers use the word energy. We are not giving a specific definition of the energy, but instead focusing on indicators of energy. And because we are looking at the collision context, we are going to specifically look at the energy of moving objects, leading us into our first concept. All things that are moving have energy. This is important for students to recognize immediately that anything that is in motion would be considered to have energy. As they are looking at objects in motion having energy, we want to focus them back to the collision and look at maybe changes in motion that happens when the vehicles collide and changes that would happen before and after the collision. If you remember in section 1.2, and you might want to remind your students of this, they looked at the motion of each vehicle, and in this case we called it the strike vehicle and the target vehicle, before, during, and after the collision. So in this case, the strike vehicle, which was the truck in the investigation, and the target vehicle, which is the car in the investigation, the students looked in sample collisions how they were moving before, during, and after the collision. In this case, the strike vehicle, often before the collision, was moving, and then during and after the collision, slowed down or stopped. The target vehicle, which was still or stopped before the collision, during and after the collision began to move and then came to a stop. There was definitely evidence of changes in motion as the students watched the collision and also as they worked with the collision model in their investigation. This would lead us to our next concept. Each of these changes in motion are the result of changes in energy in each vehicle. So it's very important for students to understand that all things that are moving have energy. So an object in motion has energy. When the object changes its motion, it also results in a change in energy. So whether the change in motion is from still to moving, that would be a change in energy, it would probably be an increase in energy, or whether the change in motion is from moving very fast to slowing down, it all results in a change of energy. So motion as an indicator of energy, changes in motion also indicate changes in energy. Now, if we continue to look at our model of our truck, which is our strike vehicle hitting the car, we also looked in our investigation at how the truck is rolling down the ramp. The truck has moving energy. It is in motion at this point. The car at the bottom of the ramp is stopped, so it does not have moving energy. However, after they collide, the truck and the car are both moving, and so they both have moving energy. Although the truck is moving, it did also have a change in some of that moving energy. This leads us into our next concept, which talks about where did the car get its energy from? How did the car start to move? How did it get moving energy? This is a perfect time to try to elicit this answer from your students. Without getting into the next concept, really facilitate the conversation. Maybe even model, again, the truck hitting the car in front of the classroom. And really get the students to come out with the answer that the truck made the car go into motion, that it might have transferred energy during the collision. This really should be a facilitated conversation, one where the students are able to come up with that answer of where did the car get its energy from, and then discuss with them how the truck transfers some of its energy to the car, and that when there are interactions such as the collision, energy can be transferred from one moving object to another when they interact. Now that the students have this idea that energy can be transferred, that a moving object can transfer energy to a still object and cause it to move, I want you to look again at the videos of the collisions. So if you can take your LS1 DVD and you're going to look at video 5, actual collisions, this is the same video that was shown during 1.2. Students should now look at these videos not in the idea of changes in motion, but now of changes in energy. In section 1.2, they focused on changes in motion before, during, and after the collision. Now we're going to look at changes in energy with regard to motion. So again, in this first video, we have our stopped car and we have our Jeep or a truck, that is our strike vehicle, causing a change in motion and therefore causing a change in energy. It might be helpful to kind of move this in slow motion and say, is the car have moving energy? Students should answer no. Okay, at what point does the car start to move? Well, during the collision. Now, does the car and truck have moving energy? And really ask some questions about which object has moving energy, which does not, and when this transfer occurs. Okay, in each collision video, it's slightly different how this transfer of energy might occur and how motion might change. So again, we have our stopped vehicle, we have our moving vehicle, and then our target vehicle is actually then moving in motion, and this car has stopped. So you can see the transfer of energy. Show all three collision videos again and really have students analyze how these videos work, and then therefore also look at the transfers of energy that are occurring during these collisions in these videos. Now that students have an understand a little bit more about energy transfer, you can move into part 2 of 2, which now discusses back to the investigation and also the context. So not all the collisions that you might have viewed in the video result in the same outcomes, which is true. We learned that, not every car had the same amount of moving energy. Cars might have traveled different distances after the collision. So remind students of that, and if you need to re-show the videos, you might show them that some of the vehicles traveled different distances after the collision. In part 1, we discussed why data may have changed from last year to this year with regard to the accidents. If you remember, there's a lot more severe accidents this year, and also when the students were looking at the maps, in those severe accidents, cars were traveling a greater distance after the collision. This is again when you become the facilitator and you start to talk about, well, why do you think some of these cars were traveling the greater distance? What does it mean? Why did some of these cars maybe transfer more moving energy? So why did the truck maybe transfer more moving energy to the car? If the transfer of energy from the strike vehicle, the truck, to the target vehicle is different, how might this explain why some cars travel further after the collision? So really do questioning with the students facilitate this conversation of how can we tell why these certain cars travel further distances? Why is there a difference maybe in the amount of energy transferred during different collisions? And then start to brainstorm, how could you test that? How could you test this difference? How could you test whether some vehicles transfer more energy and some vehicles transfer less energy? And have a class brainstorm, record that list on the board. If you notice, in addition to some of these discussions and watching the videos in 1.5, there's also a science note sheet. This sheet is really for content notes. There are 3 questions on the note sheet, and there's not a specific time within activities during 1.5 that the students are directed to go to the note sheet. As a teacher, you're going to try and think about when would be best for students to go to the note sheet. At what point are they familiar enough with the concept to start to answer some of these questions and take some notes? They might work on this note sheet in a group or individually. It would be your choice. The first question on the note sheet says, what indicates a transfer of energy between 2 objects? This might be best introduced sometime during part 1, once they've learned about energy being transferred, maybe during the videos, maybe before, maybe after. They might say, especially focusing on motion energy, that a change in motion might be an indicator of energy between objects. Some students who might be a little more advanced might also include something about sound energy, or a loud noise might be a transfer of energy if they're hearing the noise during the car accident too. So all those could indicate a transfer of energy. It does not need to be in a complete sentence, but in science notes they can refer back to this for content. Question 2, what are some examples of objects interacting where you see evidence that energy is being transferred? Again, this evidence would be a change in motion. And so obviously an easy example for the students might be after the collision videos, they're going to say truck to car to car, but you might also give them an idea of, kicking a soccer ball, a bat to a baseball. So just some other common ideas that might show differences, changes in motion, something that would cause a change in motion. That would be an example of evidence that energy is being transferred. The third question talks about what variable changes did your class suggest that they could test how energy is transferred between a strike and target vehicle in your model. Now in 1-6 they will be testing mass and speed. However, this again should be really elicited from the students, so there might be other variable changes that would occur. As a teacher, you might want to start questioning your students and say, what do you think would happen though if a Mack truck hit that little convertible at the intersection? Do you think it would go further or not? So you might want to give some leading questions. You don't want to tell them here, but you also don't want them to come to 1-6 and you tell them mass and speed and they were not on their list at all, and then the students feel that they didn't get to test some of their ideas. So this would be a great chance for some leading questions, some facilitator questions to elicit something about mass or speed in question 3.